Next, we have Rick Wagner, Treasurer of OpenSFS. Rick Wagner is the Globus Professional Service Manager, managing a team of engineers supporting organizations and research projects and solving large-scale and complex data management challenges. Prior to this, he was the HPC Systems Manager at San Diego Supercomputing Center, where he led the team responsible for several campus, state, and national HPC clusters and many petabytes of Lustre storage. Rick's starting point in research was computational astrophysics, and he's a user and supporter of open source software. Ladies and gentlemen, let's hear it for Rick Wagner.
All right, actually, let's hear it for the last talk of the day. So trying to keep this one quick, light, tell you a little bit about something we're doing with Globus, and thank you guys all for hanging out and staying around, because I thought I would be talking to an empty room. Anyway, so at Globus, I'll tell you a little bit about Globus and explain how we're tying into Lustre, but this is a project being done by a postdoc at Argonne named Ryan Chard. So he and I have been discussing his work in the concept of responsive storage. He likes to put pictures in. He helped me with the slide deck. Ryan is the one up to the top right, and to the left, that is that other Chard is the research scientist that helps lead what we call Globus Labs. These are students that are doing research into computational science problems, led primarily by Kyle and Ian Foster, and we really want to help solve the hard problems with large data. We also have a triumvirate of Kiwis. Those three folks are all New Zealanders, and I think that's the largest density of New Zealanders within a single project in the US, so we can claim that. Okay, so what is Globus? For those of you unfamiliar with it, you may know us from the background of the Globus toolkit, grid FTP, stuff like that. Globus is a combination of a piece of code called the Globus Connect server that you run on a data mover node that accesses your storage. And it talks to a cloud service that can orchestrate third-party transfers. So the cloud service handles authentication for users, talks out to the Globus Connect servers, and allows users to fire and forget transfers from something like an instrument or a workstation or an HPC facility to other places. Heavily used within the Department of Energy to move large data around over ESNet, heavily used within Exceed and stuff like that. So it also, you know, the SSH and grid FTP ghetto, as we call it, this idea that you have to add user accounts to the system for people to access data used to frustrate me to no end at SDSC. So Globus also has the ability to allow sharing of data where a researcher or user can pick a directory and share it with another individual, and then Globus will handle the access control of that. One key point about the Globus Connect server software is that it runs, when it does data access, as the local user account of the user who's accessing the data. So if I share a file with somebody, when that person comes in to access it, it's going to launch the task under my user ID. So that way, I can't share data that I don't normally have access to. And so yeah, so researchers can share stuff and get it to other people. Some marketing slides, but the important part about storage is Globus is relatively storage agnostic, and we do not take ownership of your data. So we are a federated system of data management and access control. Currently, we talk, of course, to POSIX file systems. We also talk to S3, Black Pearl by Spectra, and Google Drive, and several others. And one of the interesting conversations I got to have yesterday was with John and Stefan. The HSM code, I think it's very likely I'll be able to write an adapter that would allow users to use Globus for the HSM actions, and by doing that, Globus endpoints can mediate to the storage of choice. And this would save us from the need to have specialized copy tools for every storage, because there's already a tool that knows how to talk to these different back-end storage systems, including HPSS, by the way. We've talked to HPSS for a very long time. Okay, so that's Globus. That's the background on what the service is and does. There's other services with Globus, but primarily here, for this use case, we're focusing on this and one other. So we have a use case, right? Users want to be able to find their data, right? They generate data, they want to be able to identify it through either some catalog that they managed or a centralized cataloging service. So how can we enable a user to filter their files, identify them by MIME type, extract the metadata that's interesting for them, for their simulation, for their analysis, whatever, and then allow them to come back and search for them? You know, we store petabytes of unstructured data, and the number of researchers who say, my grad student left, where's the simulation? You know? So how do we help solve that problem? How do we solve it also for large complex workflows? In particular, our use case is based off of the advanced light source out of NERSC. So how do we allow complex workflows like the ESGF and other large projects to be able to have their metadata extracted into things like threads, catalogs, and other stuff? So our answer to this is a tool called Ripple. And I should have on here, these are the design goals for Ripple. Event-driven data management with the user being able to define the triggers and actions that takes place. Once Ripple is installed and configured, any user or developer can set up the filters on what files they want to identify and the code that they want to execute on whichever system. So that's a key point. Unlike things like Robinhood or other tools that require you to be an administrator to work with, our goal is to put the control into the project developers and users' hand to do this. I say file system agnostic, but the reality is there's only a few file system tools out there that allow you to get events like this. Of course, we have iNotify, KQ, changelogs, and so Lustre is an obvious target because we actually can get events from Lustre. And as long as we can filter them quick enough, we can take actions on them. And then because we have Globus on there, that means that any events that happen, we can take that data from one primary source and move it to another for the next stage of the workflow. So the architecture is pretty straightforward. There is an agent that would be running on the system, primarily on the nodes that are the data transfer nodes. And that's the one that's going to be triggering on particular file types. And it can have a separate one, not necessarily on the same system, but the runner that will execute the user's action. And then there's a bunch of cloud services where the users upload their triggers and events and stuff like that, and it manages the execution. Think of this as a workflow with a little w. This isn't like Kepler or Condor or something like that. We're not trying to do something massive. We want to have relatively simple if-then action. So if I'm at home, turn on my lights. You can chain those together and create more complex workflows, but this is an example of what a trigger would look like. You know, basically monitor Lustre, look for a file of create events that are .h5 files, and then if that happens, transfer them from this endpoint and run this tool and, you know, extract metadata. So we went for a prototype like this, we went pretty rudimentary when it came to the changelogs. We just basically registered as a changelog consumer so that we could get to these through LFS. Naturally, the way to go is to do something closer to what Robinhood does and actually have a changelog reader, but you know, Ryan's a little bit new to Lustre, and so throwing him into the guts of an example like that was a bit more than he could handle, whereas he's totally capable of using LFS and parsing things. And what we found so far is for the test cases that we've run, it's been adequate in terms of performance. Ripple is very, very good at filtering events. So we set up a test bed. I want to prove it could work because before somebody like Kevin lets us run it at Argonne, we're going to prove that we have functional code somewhere else on a system that's not near production. So conveniently, Intel does still maintain a cloud foundation, and you can run it for free in the T2 micro instances. So again, great place to do a proof of concept. So grab Cloud Edition, Lustre 2.8, run it on some small instances. Again, this is proof of concept and prototype. All right, so here's the where's my data use case. This is the proof of how we can do stuff. So we spun up MGS, MDS, single OSS, and then 2 clients to the Lustre file system. One to represent a compute node that's generating data, and the other one to represent the data transfer node that can move data and also run Ripple, the Ripple agents. In the cloud, there's 2 services that are part of this. One is Ripple itself, managing all the triggers and the execution. The other one is Globus has a search catalog. This is a search service that's just leaving data that's available through a web platform and a REST API. And we're using Globus Search in this instance because it's available to us, but this could be, like I said, a threads catalog. It could be your custom simulation catalog, whatever you want to store your data in. And this is just for the search example. So what happens is if the ALS simulator writes files, create events happen on Lustre within the MDT. Changelog flows over to Ripple agent, and the target events are filtered. So again, we're looking for specifically create events within a specific directory with a particular file name. So this allows us to subset the data that we're looking at. The agent talks up to Ripple. Ripple says, all right, I've got an event trigger. Fire this back to the runner that's going to execute my Singularity container. How many folks here are using Singularity? Okay, that number should go up quite a bit next year. Singularity is user space container images. It works in HPC excellently for getting arbitrary code from crazy Linux distributions like Ubuntu to run on your CentOS boxes. It is awesome. And for our purposes, I mentioned that we execute things in user space. Singularity is ideal because we already have the ability to execute things on behalf of a user. Singularity allows folks to package their applications for these type of events to get handled. So we took Singularity and we threw in a tool called Tika, which can identify files by MIME type, extract content, and help to generate the metadata files. So we threw Tika in there. Singularity gets executed. We get a metadata file. The metadata file gets shoved up into search, and now I have cataloged all of the ALS data that's being generated here. Goes into Globus search, beta UI, and this is what the content looks like from the gmeta files. So again, could be your catalog, it could be our catalog, but right now this is kind of the catalog all the data use case with a very simple set of tools. Number one question about something like this when you're dealing with changelogs is always how quickly can you filter these events? And so we've done a lot of testing in just random places to sort of compare how many events can I get per second and how many can a single agent get through. And the strongest case is if you're using iNotify on a local POSIX system, Ripple can keep up to 10,000 events per second going. So it's really quick at filtering files. On an AWS T2 micro instance with an MDT, that system can only handle 700 creates per second. Ripple had no problem keeping up with it. So I'm fairly confident that Ripple would not be the bottleneck in handling these flows because pretty much it's doing some type of regex on the files to identify them, and it's filtering most of the events away. Okay. Future work. Number one, scalability. DNE is out there. Metadata servers are going to grow in number. Data and metadata is going to happen. We're going to have to be able to keep up with a lot more events. And so we're already discussing how do we take the Ripple agents and chain them into a hierarchical model. One of the interesting things that Robert Reed mentioned was, when I was talking with him about this, is what about the possibility for Lustre itself as allowing clients to register as iNotify consumers? You know, Lustre currently could not afford to blast out every single event to every single node, but could you register a particular client directory and set up iNotify for that client? And where you have tools like Ripple running, now all of a sudden all of iNotify would become available to you. So throwing that out there as an idea. We want to have a simple programming model for the if-then triggers so that when people are writing their scripts and stuff like that that'll execute, they'll be able to run. So job runners is a challenge. Basically, you're going to want to execute something on your code in various places. Always a challenge figuring out how to get those things into various systems like HPC centers and stuff without having to reproduce Gram or Unicore or something like that. We want it to be lighter than that. Workflow management for the chaining of events, and then testing at ALCF, right? We're fortunate that Argonne has now become part of the Lustre community, and they're right next door to us. So Ryan has already been hanging out with Kevin and his staff, seeing what we can do next. So thank you very much. Try to make it a little bit early so we can have lunch and get on our way. Questions?
So is the Ripple runner become like another endpoint in Globus so you can identify that unique, like I assume those could be at multiple sites?
That's the intention, is the Ripple agent would be incorporated with Globus Connect server. So that's because that's a natural place to look for files as they're going in and out of the system. But we don't want Globus to be the single point of truth for events. We want the file system to be the single point of truth for events. The runner could potentially live in the same place if the workload is small. Data transfer nodes, data movers, typically are not heavily loaded, especially in CPU. They're just moving data around. It's quite possible that a lot of these simple metadata extraction actions could take place on those nodes, or you could have a runner that actually does stuff like submit a more complex job. It's a balance between how much resources available for compute versus how big of a thing do you want to scale up for your next step of your workflow. So we kind of have to trade off those two. All right. Mr. Sims, can I turn this back over to you?